Today our topic is playing with numbers. Okay. First, suppose Ram has given 6 marbles and she is supposed to arrange these 6 marbles in such a way that each row consists of same number of marbles. That is, 6 marbles are given to Ram and these 6 marbles are arranged in a proper way that each row must contain the same number of marbles. These 6 marbles can be arranged in 4 different ways. One way is arranging each marble in each row, that is 1, 2, 3, 4, 5 and 6. This is the one way to arrange these 6 marbles in such a way that each row consists of only one marble. Second method is arranging 2 marbles in each row. Here we have taken 3 rows here and 2 marbles in each row. Hence 6 marbles can be arranged in this way also. Next method is arranging these 6 marbles in such a way that each row consists of 3 marbles. That is 1, 2, 3, 4, 5, 6. This is also one way to arrange these 6 marbles in such a way that each row consists of same number of marbles. And last way is arranging entire 6 marbles in only one single row. 1, 2, 3, 4, 5, 6 in one single row. This is also one way to arrange these 6 marbles in one single row. These are 4 different fashions where we can arrange these 6 marbles in such a way that the number of marbles consist of in each row should be same. Next is factors and multiples. Let us take the number 4. This number 4 is being divisible with 1, that is 1 4s are 4, remainder is 0. Hence the number 4 is exactly divisible with 1. Similarly 2, that is 4 here, 2 2s are 4, 0. Similarly 4, that is 4 1 times 4, that is 0 here. Therefore the factors for 4 number is 1, 2 and 4. These are the 3 factors for the number 4. If we consider another number, that is for 8, the factors for the number 8 are 1, 2, 4, 8. These are the 4 numbers which are the factors for the number 8. If you divide with 3 number, the result will be 3 to the 6 and the remainder is 2. Hence the number 3 is not a factor for 8. So the numbers 1, 2, 4, 8 are the factors for the number 8. Next topic is prime numbers. What are prime numbers? The numbers which are exactly divisible with 1 and itself is called a prime number. Let us suppose we take a number 2. This 2 number is exactly divisible with 2 and 1. That is 1. If you take the divisor as 2 here and 2, 2 1s are 2, remainder is 0. That means 2 is divisible with 2. If you take the number 1 and 2 here, 1 2s are 2, it is divisible with 2. Hence the number 2 is a prime number. Prime number should satisfy the condition that it should consist of only exactly 2 factors. Suppose if you take 4, the number 4 is divisible with 1. 1 4s are 4 here, and 4 is also divisible with 2, that is 2 2s are 4 here, and 4 is also divisible with 4 also, that is 4 1s are 4 and remainder is 0. Since the number 4 consists of 3 factors, that is 1, 2, 4, hence it is not called a prime number. the prime number should exactly consist of 2 factors. Then it is called a prime number. The prime numbers are 2, 3, 5, 7, 11, 13 and so on. These are the prime numbers between 1 to 15. If you consider 1, 1 is exactly divisible with 1 only. That is, there is no another number to divide with 1. So it consists of only one factor. So it is not called a prime number. Let us draw one table here. Numbers, factors. 1 consists of only one factor, that is 1 is exactly divisible with only one number called 1 only. If you consider 2 number, it is divisible with 1 and 2. Since it consists of 2 numbers, since it consists of 2 factors, that is 1 and 2, it is called a prime number. Hence 2 is called a prime number. Next 3 is also exactly divisible with 1 and 3, so it is also called a prime number. Let us take 4. As I already discussed here, 4 consists of 3 factors, that is 1, 2 and 4. This is not called a prime number. Again 5 here. 5 is exactly divisible with 1 and 5. So it is called a prime number. Similarly 7. It is divisible with only 1 and 7. So it is called a prime number. If you take 6 here, 6 consists of 1, 2, 3 and 6. 4 factors. 6 consists of 4 factors. So it is not called a prime number. Next topic is composite numbers. These composite numbers are exactly opposite to the prime numbers. That means it should consist of more than 2 factors. As 4 consists of 3 factors, that is 1, 2 and 4. These are the 3 factors for 4. Then it is 4 is called a composite number. Let us take 6. 6 consists of 1, 2 and 3. This also consists of 3 numbers, 3 factors which are divisible with 2, 6. That is 6 is also called a composite number. Let us consider 7. 7 is divisible with 1 and 7. This is not a composite number. Since it consists of only 2 factors, that is 1 and 7, it is not called a composite number. Hence it is called a prime number here. Similarly 8 here. 8 consists of 1, 2 and 4. It consists of more than 2 factors. So it is also called a composite number. Now next topic is test for divisibility. Let us take numbers 2, 4, 6 and 3 here, 5, 10, okay, 9 here. The number which is divisible with 2 must exactly consist of even numbers at their unit places. That is, it should contain 0, 2, 4, 6, 8. These numbers should be placed exactly at their unit places. That means 100. The unit place consists of 0 here. So 100 is exactly divisible with 2. If we take 103, since 3 is odd number here, it is not an even number, so it is not divisible with 2. Let us check here. 2 with 103 with 2. 2 5s are 10. 0. 3 again. 2 1s are 2. Remainder is 1. So 103 doesn't satisfy the condition for divisibility test here for 2. If we take the number 104, where 4 is an even number in its units place, if we divide with 2, 2 5s are 10, 0, 4 here, 2 2s are 4. Hence, the number 104 is being satisfying the condition for test for divisibility number for 2. So, whatever the number may be, the units place must exactly consist of these numbers 0, 2, 4, 6 and 8. If the number consists of 0, 2, 4, 6 and 8 are the units places, then the number is going to be supposed to divisible with 2. Now, test for divisibility test for number 3. Let us take the number 12. The condition for test for divisibility test for 3 is, if we add these two numbers, the resultant should be exactly divisible with 3. 1 plus 2, the result is 3. Hence 3 is exactly divisible with 3 also. That is 3 with 12. 3 4s are 12. Remainder is 0. So 12 is being satisfying the condition here. If we take the number 13, if we add these two numbers, that is units place and tens place, 1 plus 3, the result is 4. 4 is not divisible with 3. So the number 13 is also not divisible with 3. Let us check here. 3 with 13 with 3. 3 4s are 12. The remainder is 1. So it is not divisible. Here the number 13 does not satisfying the condition for test for divisibility number for 3. So the condition for test for divisibility test for 3 is, if we add the numbers, that is units place, tens place, if we even take the hundreds place also, the number should be exactly divisible with 3. Then the number is going to divide with 3. Suppose if we take 3 numbers, 9, 9, 9 here. If we add these 3 numbers, 9 plus 9 is 18, 18 plus 9 is 27. Since this 27 is divisible with 3, hence the number 999 is also divided with 3. Let us check here. 9, 9, 9 with 3. 3 3s are 9 here, 0, again 9, 3 3s are 9, 0, again 9 here, 3 3s are 9. Hence the condition is being satisfying here. Take another example. If you take 555, we have to add these numbers 5 plus 5 plus 5. 5 plus 5 is 10, 10 plus 5 is 15. Since the number is 15 is exactly divisible with 3, hence the number 555 is also divisible with 3. Let us check here. 3 with 555. 3 1s are 3, 2 carry, again 5 here. 3 8s are 24, 1 and again 5 here. 3 5s are 15. So it is satisfying the condition. So the number 555 is exactly divisible with the number 3. Hence the condition is satisfied here. Test for divisibility test for 4. If you take the number 4, what are the properties here? Should be the last 2 digit number, that means units place and tens place, should be divided with 4. That means the units place and tens place should be in such a way that the 4 should be divided. Suppose 6 and 1 are respectively in units place and tens places here. 4 divided with 16. 4 4s are 16. 0. Since the units place and tens place is exactly divisible with 4, then the condition will be satisfied. If we take 3 digit number, let us suppose 924. The units place and tens place are exactly divisible with 4. Hence 924 number is also going to divide with 4. Let us check here. 924 with 4. 4 2s are 8, 1 carry, 2 here, 4 3s are 12, 0, 4 again, 4 1s are 4 is 0. Hence the number 924 is exactly divisible with 4. Whatever the number may be, the units place and tens place should be divided with 4. If the number of units place and tens place are going to divide with 4, then the whole number is going to divide with 4. Next is test for divisibility test for 5 with 5 number. Here the units place should exactly consist of either 0 or 5. That means it should consist of 0, 5, 10, 15, 20, 25, 30, 35 and so on. That means the units place should exactly consist of either 5 or 0. If you take the number called 1005 and check the condition here, 1005 with 5, 5 2s are 10, 0, again 0 here, 0 here, take 5 here, 5 1s are 5, 0. Hence the condition is proved here. Hence the number 1005 is exactly divisible with 5. So the condition for test for divisibility test for 5 number is the units place should either consist of 0 or 5. Next, test for divisibility test for number 6. For this number, whatever the number may be, let us take number 12. The number should divide with 2 and 3 both. If the number is going to divide with both the numbers, that is 2 and 3, then the test for divisibility test for number 6 is going to be satisfied here. That is 12 with 2, 2 6 are 12, 0 remainder, again 3 here, 3 4s are 12. Here both numbers 2 and 3 are being satisfying here. So the condition test for divisibility test for 6 also satisfies here. Let us take another example, that is take the number 36 here and check whether the 36 number is being divisible with 6 or not. 36 with 2, 2 1s are 2, 1 carry and 6, 2 8s are 16. Condition test for 2 is being satisfying here. Next for 3 for 36, 3 1s are 3, 0, 6 again, 3 2s are 6, 0. Here the condition is satisfying by both numbers 2 and 3. Hence the condition test for 6 also satisfies here. Let us check here. 36 with 6, 6 6 are 36, remainder is 0. Hence the condition is being satisfied here. Now test for divisibility test for 8. It is little bit quite extension passed for the test for divisibility test for number 4. That means here units place and tens place and hundreds place should be divided with 8. Here for these numbers, units place, tens place and hundreds places should be divided with 8. Hence the entire number will be divided with 8. If it satisfies means the entire number will be divided with 8. Let us take the number 24, 024. Here hundreds place is 0, tens place is 2, units place is 4, and check the condition here. 0 1 2, 8. Since 0 cannot be divided with 8, we take 2 numbers at a time. 0 2, 0 2 is also not divided with 8, so we take 3 numbers at a time. 8 3s are 24, 0. The remainder is 0. Hence the condition is being satisfying here. So the number 024 is being satisfying. So 8 is divisible with 24. Next, if we take 3-digit number, that is other than 0 at unit hundreds place. Let us take 816, 3-digit number. This 3-digit number should be exactly satisfied with the 8 number. That means if you suppose take here 8 with 816, 8 1s are 8, 0, again 1 here, 0, again 1, 6, 8 2s are 16, remainder is 0. Hence the number 816 is being satisfied with the number called 8. Hence test for divisibility test for number 8 is satisfied here. If we take 4 numbers, let us take 8, 2, 4 and 9, 9824. Since these 3 numbers, that is 8, 2, 4 are being divided with 8 number, so the entire number 9824 is exactly going to divide with the number called 8. Let us check here. 8 1s are 8, 1 carry, again 8, 8 2s are 16, 2 here, bring the 2 down here, 8 2s are 16 again, 6, 4, 8 8s are 64, remainder is 0. Hence the number 9824 is being satisfied with the number called 8. So test for divisibility test for number 8 is satisfied here. Whatever the number may be, if you take the 5-digit number, the last three numbers, that is units place, tens place and hundreds place, should be exactly divided with 8. If it is supposed to going to divide with these three numbers, then the whole number will be going to divide with the number called 8. Next, test for divisible test for 9. It is just similar to the test for divisible test for 3. That means, suppose take the number 18. We have to add these two numbers, 1 plus 8, that the result is 9. Since 9 is divisible with 9, so the number 18 is going to divide with 9. We check here, 9 with 18, 9 2s are 18, 0. Hence 18 is going to divide with 9. Hence the condition satisfies here. Next example is 36. Add these two numbers, 6 plus 3, again 9. 9 is again going to divide with 9. So the number 36 is going to divisible with 9. Hence the test for divisible test for the number 9 will be satisfied here. 9 with 36, 9 4s are 36, remainder is 0. If you take 3-digit number, let us take 3-digit number here, 918. We have to add these three numbers, 9 plus 1 is 10, 10 plus 8 is 18. This 18 is being divisible with 9, so the number 918 is also going to divide with 9. Let us check here, 9 with 918. 9 1s are 9 here, 0, 1 here, again 0, 1 8, 9 2s are 18. The remainder is 0 here. So 918 satisfy the test for divisibility number for the number 9. Hence the condition satisfies here also. If we take the number 922, add these three numbers, 9 plus 2 is 11, 11 plus 2 is 13. 13 is not divisible with 9, so this number is also not divisible with 9. Let us check here, 992 with 9, 9 1s are 9, 0, 2 here, again 0 here, 9 zeros are 0, 2, 2, 9 2s are 18. We get the remainder 4. So the number is not divisible with 9. So the test for condition divisible test for this number 9 doesn't satisfy here. Next, the last number is test for divisible test for number 10. For this number, the units place should be 0. That means either it should be 100, 150, 110, 120, 130 and so on. The units place always should be 0 here. If the units place is 0, then the number going to be divided with 10. Let us take the example 150. Divisor is 10 here. 10 1s are 10, 5 carry and 0, 10 5s are 50. So the number is going to divide here. If you take 155 with 10, 10 1s are 10, 5 carry, again 5 here, 10 5s are 50. The remainder is 5. So this condition doesn't satisfy here. The units place should exactly consist of 0 only. Next topic is HCF. HCF is nothing but highest common factor. Let us find the HCF for two numbers, that is 20 and 28. For this we have to find the common multiples for multiples of 20 and 28 each. 20 multiples of 20, 2, 2 and 5. That means 2 2s are 4, 4 5s are 20. Next number is 28. Multiples of 28. If you want to find the multiples of 28, we can do like this. That is 2 1s, 2 4s, 2 7s, 2 2s are 4, 4 7 are 28. That is multiples of 28 are 2, 2 and 7. The common factors between 20 and 28 are only these two. These two numbers are common factors for 20 and 28. And the highest common factor, that is highest common factor is these two only, 2 1 2, 2 1 2, that is 4. 2 2 the 4, 2 2 the 4. The number is 4 and 4 here. 4 and 5, 4 into 7 here. That means the highest common factor in these two numbers is 4 and 4. Hence the HCF of 20 and 28 is 4. Let us take another example. Ten and 16. 10 and 16. 2 5s are 10. 10 equal to 2 into 5. 2 and 5 are multiples of 10. Next is 16. 2 8s are 2 4s are 2 2s are 4. 4 4s are 16. Again we can also divide this 4 also. 2 2s are 2 2s are 4. 4 2s are 8. 8 2s are 16. 2 into 2 into 2 into 2. The common factor of 10 and 16 is only 2. The highest common factor is also 2 here. That is these 2 only. Then the HCF of 10 and 16 is 2. Let us take another example. If we take 3 numbers at a time, let us consider the numbers 20, 28 and 36. And we have to find the HCF of these 3 numbers. First find the multiples of 20. 2 1s, 0s, 2 5s, then 2 2s are 4, 4 5s are 20. The multiples of 20 are 2 into 2 into 5. Next, multiples of 28. 2 1s, 2 4s, again 2 7s. Multiples of 28 are 2 into 2 into 7. Next, find the multiples for 36. That is 36 of 2, 2 1s, 1 carry, 2 18s, again 2 9s, again 3 3s. The multiples of 36 are 2 into 2 into 3 into 3. The common factors of these 3 numbers, that is 20, 28, 36 are 2 into 2, 2 into 2 and 2 into 2. That is 4 is the common factor of these 3 numbers, that is 20, 28 and 36. That is 4 into 5, 4 into 7 and 4 into 3 into 3. And the highest common factor is also 4. So for the numbers 20, 28 and 36, the HCF is 4. Next topic is LCM. LCM is nothing but lowest common multiple. Lowest common multiple. Find the LCM of 4 and 6. Let us consider these 2 numbers and we have to find the LCM for these 2 numbers. 4 and 6. 2 times and 2 3 times. We can't further divide these 2 numbers. So LCM for 4 and 6 is 2 into 3. That is 2 2s are 4, 4 3s are 12. LCM of these 2 numbers 4 and 6 is 12. Let us take another example. (16) and 20. Find the LCM of 16 and 20. LCM of 16 and 20. 16 and 20. 2 8 times, 2 10 times. Again with 2. 2 4s, 2 5s. This can't be divided further again. So LCM of 16 and 20 is 2 into 2 into 4 into 5. Then the result is 2 2s are 4, 4 4s are 16, 16 5s are 80. 80 is the result for LCM of 16 and 20. Let us take 3 numbers at a time. and find the LCM of these three numbers. Let us take the numbers as 24, 48 and 72. Let us find the LCM of these three numbers, 24, 48 and 72. 24, 48, 72. 4. These two numbers are divisible with 4. 4 6 are 24. Again 4 1s are 4 2s are 4 1s are 3 carry 3 2 4 is 32. Again these three numbers are being divisible with 6. Since the units place and tens place for these numbers are exactly divisible with 2 1 3. So the condition for 6 also satisfies here. 6 1s are 6, 6 2s are 6 3s are. LCM of 24 and 40, 24, 48 and 72 are 4 into 6 into 1 into 2 into 3. 6 4 the 24, 24 into 6, 24 into 1 into 6, that is 6 4 the 24 here, 2 carry 6 2 12, 12 plus 2 144. LCM of 24, 48 and 72 is 144. Let us take another example by taking three numbers at a time. 12, 9 and 5. LCM of 12, 9 and 5. 12, 9 and 5. 12, 9 are exactly divisible with 3. 3 4s are 12. 3 3s are 9. 5 cannot be divided with 3. So we keep 5 as it is here. We can't further again divide. We can't further divide these three numbers. So LCM of 12, 9 and 5 is 3 into 4 into 3 into 5. 4 3s are 12. 12 3s are 36. 36 into 5. The result is 6 5 are 30. 3 carry. 5 3s are 15. 15 plus 3, 18. That is 180. LCM of 12, 9 and 5 is 180. Thank you.